Welcome to session 153 of the podcast. Today we're talking about splitting antennas to multiple scanners. All the session notes can be found on our website at scannerschool.com/session 153. Before we start this week's podcast, I'd like to take a moment to thank our Patreon supporters. Patreon is a month-to-month sponsorship platform. We have 3 different support tiers, each with different benefits. But the most valuable tier is our $5 a month tier. This equates to sponsoring the podcast for about $1 per episode. Now, not only do our $5 Patreon supporters receive the podcast early, but they also receive a commercial-free version of the podcast delivered directly to their podcast player. Some may say that the included Squelchy sticker pack that is mailed to your home is the best benefit of the $5 level, but I think it's the community or the club that is growing at this level. You see, we meet once a month on Zoom and we have a roundtable discussion about scanning, ask questions, offer advice. Some of the members are answering other people's questions, and we just talk with our fellow Scanner School classmates. This is an exclusive group for our $5 Patreon members. Now, again, if all this wasn't enough at that level, you'll also receive discounts to upcoming Scanner School courses and offerings. Now, you can help support Scanner School by going to www.scannerschool.com/Patreon or www.scannerschool.com/support. Now, I'd like to thank all of our Patreon supporters at all levels, and they are Brian King, Buzz Gold, Chris Paris, Craig Harper, Dan, Ed Walsh, Eddie K, Edward Dufour, Glenn Bryden, Guy Lee, Jackson Freeman, James Felling, James Peruta, Jeff Block, Jenny Taylor, Jim Heinrich, John Goldenberg, Ken Newberry, Kenneth Fowler, Kevin Zwicky, Lenny Bauer, Mark Thompson, Mark Beebe, Michael Kroger, Paul Teal, Raymond Hill, Richard Armstrong, Ronnie Bach, Sal Marandola, Tim Mazza, Todd Glendy, and William R. Can. Now let's start the podcast.
Welcome to The Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
Welcome to Scanner School. My name is Phil Lichtenberger, and my amateur radio call sign is W2LIE. Today's podcast is sponsored by our Patreon supporters, as well as East Coast Pagers, your emergency alerting specialist. You can visit East Coast Pagers at eastcoastpagers.com, and don't forget to check out our Black Friday and Cyber Monday deals, probably still going on, by listening to the ad in the middle of the podcast. So if this is your first week joining us for class or you're a weekly listener, welcome back to this week's podcast. A few weeks ago on session 153, we talked about combining multiple antennas into a single radio, and also about splitting those antennas back out again if you wanted to share a single coax line. And that was the trick in that session, right? Was bringing in multiple antennas into a single coax line and bringing them into a radio. Well, a few weeks ago on session 151, we talked about combining multiple antennas into a single radio. And we also talked about splitting those antennas back out again if we wanted to share a single coax line. Well, this week we're kind of flipping that upside down, and we're going to take one antenna and split it out to multiple radios. Now, if you want to go back and listen to that previous episode, it's at scannerschool.com/session 151. But let's do a really quick review of that session here. So we talked about using diplexers, triplexers, quadplexers, and possibly even a duplexer to combine multiple antennas into a single coax line. Now, again, why would we want to do this? Well, first of all, coax, especially LMR 400, can be a little bit pricey. It's about $1 a foot, maybe a little bit less. But we're talking about maybe setting up a really good VHF-UHF combo antenna, which you can buy for about $100 in the amateur radio market, maybe even a omnidirectional high-gain 700, 800 megahertz antenna, and then using, a discount antenna to fill in anything below the VHF public safety band. Well, let's take all of these antennas, all 3 antennas, and combine them and then send them down into our radio room using one piece of coax. That's the game here. So instead of us costing $3 a foot, because we have to run 3 lines of coax, it costs us $1 a foot, right? It's a lot more affordable to share this coax line. Now, this also assumes we can find off-the-shelf equipment, because I did some research. I couldn't find a triplexer that would allow us to do this configuration. Maybe we stacked a diplexer, but again, in theory, and that's what we're talking about here right now, in theory, is the fact that we're going to combine these 3 antennas in this configuration, bring it down into a single radio. But what happens if we want to split these antennas again in the radio room? Well, you could take the same diplexer, triplexer, quadplexer, etc., and then split out the signal again to different radios. So again, let's just say that in a theoretical environment here, we've got a couple of radios here, right? We've got a VHF radio we're going to set up for VHF Marine. Maybe we have a UHF radio we're going to be monitoring UHF Public Safety. And then we have a 700, 800 radio that we're going to be monitoring a trunk system. So again, you can bring these antennas down on a single line of coax. Again, use a theoretical triplexer here that doesn't exist, and split the signal back to each one of these radios independently. Now, why would we want to split these signals using diplexers, triplexers, quadplexers, etc., when we could use something else that just splits all the frequencies? Well, we're going to just limit what the receivers want to receive, what they are made for. And this will help make the receiver a little bit more sensitive, because we're not overloading the front end with, say, we're not sending 800 megahertz to the VHF or UHF to the VHF radio. Likewise, with the UHF radio, we're only sending UHF frequencies. We're not sending VHF or 800. So, for example, if we were close to an FM transmitter site for FM radio, or if we were close to an airport, or we had paging on, say, the different bands, well, the UHF radio is only going to get the UHF spectrum. It's not going to get the aviation band. It's not going to get FM broadcast band. And it won't get paging up in the 900 megahertz range, because we're filtering those out. So that really helps that UHF radio out very well. Same likewise goes for, say, the VHF radio, right? We're going to omit the paging or the cellular services that are up in the 800, 900 range. We're going to clean those out. So again, that VHF radio doesn't have to worry about all that RF raising the noise floor, and we are now making that radio a little bit more sensitive. So that's why you'd want to split the radios or the signal using splitters in that, or diplexers, triplexers, etc. Right? We're basically using them as a splitter. But again, this is a more advanced way of looking at splitting antennas. We want to split one antenna equally to multiple receivers, right? The trick here is to make each scanner believe that it is connected directly to, say, your disc cone antenna, and it can receive the whole path, basically, of what the receiver is capable of. Well, back in session 33 of the podcast, we talked about multicouplers. Now, the problem I now realize, though, is between going through our Zello nets and listening to questions that come in through the Ask Scanner School channels and whatnot, is not everybody understands what a multi-coupler is or how it's used. They want to know, the general question is, how do I split my antenna to multiple radios? And the simplest answer is, well, you use a multi-coupler. And that's why we're revisiting that episode, to kind of address the question in a different way. So if you've listened to that radio and you're binging on a bunch of podcasts, I'm going to apologize, because a lot of this has gone back to session 33. But in my defense, we are at the tail end of 2020, right? This is a November podcast in the year 2020. The session 33 podcast came out way back in August of 2018. So we've passed 2 years on this. We have permission. I'm giving myself permission to repurpose this content here, because it has been a while since we've talked about it. Now, the technology hasn't changed here, but again, I understand that not everybody was listening to the podcast 2 years ago. Not everybody goes back and listens to episode 1. So to kind of reintroduce this doesn't hurt. It definitely does not hurt. And again, maybe you did listen to this 2 years ago, and I'll refresh your memory about what a multi-coupler is. And this might be one of those things, oh yeah, I meant to buy one of those. Let me take a look at this again. So exactly what is a multi-coupler, and why would we want to use one? Well, a multi-coupler can be thought of as a splitter, except there is separation between each port. Now, why do we want separation between each port? Well, we want separation because we don't want each scanner to kind of talk to each other. And I'm going to give kind of an example here as to what happened. I'm pretty sure I used the exact same example in the multi-coupler episode back in 33. But I have a buddy of mine. He's actually feeding a live feed to me. And he has a scanner set up in one room of his house that has the dispatch channel. And he's got a scanner in another room of his house that has the fireground channel. Well, he couldn't figure out, though, is why every time the dispatch scanner would receive a dispatch transmission, why he can hear it in the other room on the scanner that has the fireground frequency in it. Well, somehow magically, we discovered that he just had a cable TV splitter up in his attic, and that's what he was using to split the signal. Well, there's no separation, and one scanner just happened to somehow feed back across the RF antenna path into the other receiver and was then screwing up the other receiver. So that's kind of why you want isolation between the ports. You don't want the different receivers to talk to each other or to even introduce a load, right? Because we know from talking on previous podcast episodes that your scanner expects to have a 50 ohm of impedance on the transmission line, right? Your coax line. Coax lines, by the way, are called transmission lines, even though we're using them to receive. Now, we expect 50 ohms there. Now, if you're going to start stacking T's or types of jumpers or daisy chaining things, right, you're going to change the characteristics of your coax. You may inadvertently, too, create a filter, which may reject RF as well. So again, we're being very cautious here, and multicouplers are really the trick here. Now, we have a couple of different flavors of multicouplers. We have a passive multicoupler. Now, passive devices are generally cheaper. And again, they have no gain, and they definitely introduce loss between the ports. So let's think about something that most of us are familiar here when it comes to passive splitters. Well, many of us are familiar with cable TV splitters or just standard antenna splitters from our TVs. Basically, you have an input on one end, and then you have one or many outputs on the other end. And that's a passive device, right? It comes in, it goes out. Even our diplexes we talked about, on 151 and the beginning of the podcast here, those are passive devices. We are going to have some sort of an insertion loss when it comes to putting in a passive device like this. Typically on a cable TV splitter, you're looking between 3 dB, 6 dB, even 9 dB of loss on ports, depending how many ports you have here. Now think about this. 3 dB is doubling your power in RF. So if you're going to lose 3 dB, means you're going to lose half the RF that comes into you. That's kind of a way you can think about it. Probably somebody who's a better engineer than I am is screaming at the podcast right now saying, well, exactly. Well, listen, loss is loss here, right? The more dBs you lose, right? The more you lose in dB is a better way of saying that one. The more you're going to be filtering out. So that signal that could be just getting in there, just barely getting by and break and squelch in your receiver is now gone. You can't hear anymore. You filtered it out by using one of these passive splitters or passive multicouplers. Well, the opposite of a passive multicoupler is an active multicoupler. Active multicouplers, you plug into the wall. You have to generate or give it some sort of voltage because there's active circuits in it. And what happens with an active multicoupler is the insertion loss is negated by a little bit of preamplification in the circuitry. Sometimes you may actually get a little bit of gain out of it overall. But the whole point of an active multicoupler is to mimic basically connecting it directly to the antenna. Okay, so the active multicouplers, again, they cost a little bit more money, but you get what you pay for here. I recommend active multicouplers, especially when you're going to be doing a lot of splitting, or if you have to start daisy chaining multicouplers. That's a thing. But again, if you have an 8-port multicoupler, if you hit the divide, if every port divides out by 3 and you've got 4 ports, you start stacking on the losses here. An active multicoupler allows you to regain those losses, basically. So again, why do you use multicouplers here? Because it basically mimics, like I said before, it mimics plugging each one of those radios directly into the antenna line. Sometimes, especially with an active multicoupler, you will get some gain off of that. A passive multicoupler, you'll lose a little bit, right? You'll get a little bit of loss on there. But the key here really is that you are isolating each port. Each radio port on a multicoupler is independent of the other one, right? You will not get any type of crosstalk between the radios. In other words, and I've said it before, the radio thinks and it's acting as if it is connected directly to the antenna. All right, so we got some more information about multicouplers right after this break. Did you know there are ways to help support the Scanner School podcast that doesn't take any time or any extra money on your part? If you go to scannerschool.com/support, you will find we have several ways that you can continue to do your online shopping and help support us. We have links to Amazon. If you click on our link before you go to Amazon, anything you buy from there will help support Scanner School. Now, if you're in the market for a brand new scanner, an antenna, other accessories, we have links to Scanner Master, where you can not only purchase a scanner and accessories, but you can also get your radio programmed. And by clicking on our link before you buy, you are helping to support the podcast. Now, if you're in the market for software, we have links to Butel. And if you want something new to you, we also have links to eBay. Again, just go to scannerschool.com/support before you make your purchases, and you are helping to support Scanner School at no additional cost to you. This session of Scanner School is sponsored by my company, East Coast Pagers, your emergency alerting specialist. I want to tell you quickly about the Black Friday and Cyber Monday deals over at East Coast Pagers. Now, Unication's offering a $75 savings on all G Series voice pagers until December 23rd, 2020. But East Coast Pagers is going to enhance that deal by offering a free belt clip, a spare set of batteries, and a free case and free shipping on all G1 pagers. G2 through G5 pagers will include a $75 instant rebate, plus a free spare belt clip, a free OEM screen protector, free shipping, and your choice of a free spare battery or free nylon case. Now, check out eastcoastpagers.com for information on these Black Friday, Cyber Monday specials, and also the deals on our Swiss phone pagers. Again, that's eastcoastpagers.com, your emergency alerting specialist. Do you have a new scanner? You're having problems understanding how it works? Maybe you're new to the entire Home Patrol database of programming and you can't figure out Sentinel. Did you get a new SDR and you're trying to figure out how to install it? Or you want to learn how to use Unitrunker, DSD Plus, maybe set up a PieAware, or even just make some changes and you don't understand how the system and the equipment works? The podcast might be great for you, but maybe you need a little bit more of one-on-one help with setting something up. I'm available to do just that with you with our private tutoring sessions. You can book me online by going to scannerschool.com/consulting for a 1-hour session. And it's great because we can actually share computer screens remotely, and I can guide you through step by step as if I was sitting right next to you. So again, book me for an hour at scannerschool.com/consulting for your scanner radio one-on-one tutoring session. National Communications Magazine is your personal library of scanner, CB, GMRS, FRS, MURS, and two-way radio articles written by the best minds in the business over the past 3 decades. Your NatCom personal online access account allows you to download the newest issues of America's Hobby Radio magazine, as well as back issues too. So visit natcommag.com to download your free sample issues and sign up today. That's natcommag.com for National Communications Magazine. All right, so we talked about multicouplers, passive and active, before the break and why we want to use one. Now, let's just really quickly here talk about why we don't use T-connectors. Now, T-connectors, again, the radios can talk across the coax line to each other. They can interfere with each other. They can oscillate. There's instances too where you can probably hear the radio scanning and hear from the oscillator inside, from the IF, right? There's tons of things that can happen across these coax lines. And while I am guilty of using T connectors, I use them because they're a lot cheaper than using a multicoupler. I limit them. I really do limit them. So right now in my setup, I do have my multicoupler, one leg actually pigtails off and then tees into a couple of temporary setups that I have set up, only because it's a lot faster for me to just run these tests that way as opposed to running and dedicating another line off the multicoupler. Now, again, like I said, is it the right way of doing it? No, but I'm not seeing a negative effect right now on that leg of my multicoupler, so that is why I am doing that. Is it the right way of doing it? Absolutely not. Do I recommend doing it? Absolutely not. Okay, so what are the benefits of using a multicoupler? Again, a single antenna can be used, okay? You can also tie in your multicoupler into a ground plug on your receive station. There's usually a ground lug on there. You also can use a single lightning arrestor on your antennas. You have one antenna line that comes in, one antenna, one coax run, right? It is a little bit pricey for a multi-coupler, but you are saving yourselves coax runs, antenna placements, and those kinds of headaches as well. Now, again, differences between a multi-coupler and a splitter is a regular splitter, like a cable TV splitter, does have a dB loss. It has insertion loss on each port. And even, like we said before, diplexes, triplexes, duplexes, they all have insertion loss as well. T connectors, again, they will attenuate some signals. They could inadvertently create a filter that changes the impedance of the coax. And again, radios can talk to each other. So where do we want to place our multi-coupler? Well, I place my multi-coupler behind my desk that all my radios are mounted on. And it just makes a great central point because now all of the jumpers coming off of the scanners are as short as possible. I don't want to put the multi-coupler as soon as it comes in the house because, again, then I'm still running long jumper lines. Basically, at the back of the desk, behind the radios, that's where you want your multi-coupler to be. Again, you're also going to be able to run power to it if it's an active multi-coupler, so think about that as well. Again, there's a grounding lug on them, which is really nice. So it does allow you to ground out your receive lines to your grounding bus that you should also have in your shack as well. So what do you want to look at when you are buying a multi-coupler? Because again, there's plenty of different multi-couplers out there. Well, first of all, you want to make sure that the multi-coupler you are buying is going to work for the RF environment you want it to work in. Multi-couplers do have cutoff ranges. There's a couple of that are out there that cut off below 30 megahertz. Well, that's not going to do you any good if you are trying to receive UHF, VHF, or 700, 800 trunking. If the multi-coupler filters out anything over 30 megahertz, basically, you might also just unplug your antenna. Likewise, the one I have will basically cut off anything lower than 30 megahertz and goes up to a gig. So what does that mean? Well, that means I can't use my disc cone antenna to receive anything lower than 30 megahertz. I have to remember that. So again, if I ever want to use my disc cone antenna for that, which again, right now I'm scratching my head, I wouldn't be able to use that my multi-coupler for that. Well, the other thing you got to watch out for too is the type of connector on your multi-coupler. Is it BNC? Is it SMA? Is it an N connector, right? Look at these things before you buy your multi-coupler. Again, you want to double check too which ones you're buying. Are you buying a passive multi-coupler or an active multi-coupler? Make sure that the one you're buying is exactly what you expect to get. Also, if you're comparing multi-couplers, compare the signal loss, the insertion loss, if you're buying a passive multi-coupler. So what multi-coupler do I recommend? Well, personally, I'm using a Stridsberg multi-coupler. Specifically, the model number on that one is an MCA 208M. Now, again, if you want to see this one, you want to buy this one, I have a link to this over at ScannerMaster. Just go to scannerschool.com/multi-coupler. Again, this one isn't exactly cheap. It's $335, about what I paid for it. The price hasn't really fluctuated on that one at all. But again, it gives you all straight around BNC connectors. You have a common input at the bottom of the unit, and it lights up on top to let you know that it's got power to it. It requires 12 volts, which again is the same plug that comes with your unit in and Whistler radios, same barrel size and everything. So you have extra ones of those laying around the house. You can just plug those into the multi-coupler as well. And it gives you 8 BNC connections to go out to 8 different radios. So again, I really like to recommend this multi-coupler here, the Stridsberg MCA 28M. And again, we have a link to this on our website at scannerschool.com/multi-coupler. Now, again, this will also take you to the page too, where you can, if you've got money to burn, you can also buy the 16-port VHF UHF receive multi-coupler, which is a whopping $845 as we speak right now in ScannerMaster. And that must be a new product because I haven't seen that one listed yet or on a while on the Stridsberg website. So that's great as well too. But just to compare things here, we've got a 4-port receiver multi-coupler that is an active one, and that one is $199 as well. So the difference in price between a 8-port and a 4-port is pretty ridiculous. So that is interesting as well. But Stridsberg isn't the only multi-coupler manufacturer on the market. So there's another website from digital-loggers.com, and I've been eyeballing this one for quite a while. This is a rack-mounted 16-port multi-coupler, and this one is only $295, so it's a fraction of the price. Basically, it's about $40 cheaper from the Stridsberg 8-port, but this is a 16-port rack-mountable active multi-coupler as well. I've really been wanting to try this one and to see how well it works, to be honest with you. And again, I like the fact that it's rack-mounted, but I don't like the fact that it's forward-facing rack mount, which means that all the jumpers come out the front of it. I think it'd be a lot cleaner if it was behind it, but again, whatever works works for you. And it looks like it's got an end connector as the input, and it's got BNCs as the output, which again is great because all of our radios use basically BNC connectors. So again, that one is over at digital-loggers.com. And again, we'll put a link to this in the website at scannerschool.com/session 153. So again, multi-couplers, fancy splitters is really what they are. Again, they allow us to bring the signal and split it out to each radio, mimicking basically the fact that each scanner is independently plugged into the scanner antenna. Again, we like these because they don't crosstalk. There's no interference between one radio and another. Everything is isolated. An active multi-coupler gives you a little bit of gain and overcomes the insertion loss. Passive multi-couplers are definitely cheaper, but there will be a little bit of loss on the multi-coupler. Again, you want to make sure when you buy a multi-coupler, you find one that's in the band split you need. Again, the one I recommended before, the one I use, covers from 30 megahertz to a gig. I've been using it for years, and I'm going to basically cry the day that it ever decides it's not going to work anymore. My entire scanner setup runs on these multi-couplers, so it is definitely interesting. And again, it's one of these devices people ask all the time, how do you split antennas or split your antenna to multiple receivers? The right way definitely of doing it is a multi-coupler. Don't think I could say it anymore. I think I beat this dead horse. So with that, we're just going to let it go. Again, you can look at the session notes online by going to scannerschool.com/session 153. And remember, you can join us every week, or just about every week, on Tuesdays for our Zello net. Go to scannerschool.com/Zello to get the information on our weekly net. And also, if you are subscribed to this podcast, I want to just say thank you very much for your continued subscribing and downloading of the podcast. But if you're not, why don't you go ahead and take your podcast player out of your pocket and click on that subscribe button so you get next week's podcast delivered right to your device. And again, if you've enjoyed the podcast too, why don't you share this with somebody else that you know that's in the scanner radio hobby, whether it be on a email list or a Facebook group or even on your Twitter account. This is how we spread the news that Scanner School is out there so that others can also enjoy the podcast and learn a little bit as well. So again, we will catch you all again next week. And we're getting into December. It's this year, hopefully, ends on a positive note after everything that happened so far this year. We'll catch you all next week. Again, this is Scanner School. We teach everything you need to know about the scanner radio hobby. 73.